Hi everyone. Thanks for joining us and welcome to the Edinburgh DevOps User Group. Today we're joined by Matt Laver and Rafael Ramos from AWS to cover AWS DevOps and how that's evolved at Amazon. So just to give you a bit of information about what we'll be doing today. So we have a presentation which will start in a few minutes and I'll hand over to Matt. Then we'll have a demo just after the presentation and a Q&A session just at the end. If you have any questions during the presentation, in GoToMeeting there's a chat function where you can ask questions in there and we'll round those up at the end and ask them to Matt and Raphael as they go. And with that, I'll hand over to Matt to get us started.
Hi, thank you very much, John, for the intro, and thank you for inviting me here to talk at the at your event. Hopefully you can see my screen with the slides, which is good. So as John mentioned, what we're going to do here today is I'm going to talk a bit about DevOps at Amazon and the journey that it's been on, which is quite a long journey. It's going to be quite a sort of a high-level overview of some of the principles that were in play and some of the challenges that were had. And then I'm going to pass on to Raphael, who will talk about something that we've sort of loosely coined as a sort of a next-gen DevOps principles and tools. So I'm Matt Laver, I'm a solutions architect at AWS. My main role here is to work with customers to offer technical guidance on the implementation of their solutions. And what I'm going to do, with further ado, is start talking about the DevOps at Amazon. So when we talk about DevOps at Amazon, there are three laws that we like to discuss. So the three laws of Amazon DevOps. And these are things that have helped us become more productive, faster, build smaller teams to build more. And the first of these is we break things down. So, and this doesn't just apply to software, this applies to principles in general. So we like to break things down into smaller componentized parts that can be managed independently. The second thing is that the teams are anonymous, so they're autonomous businesses. So what we mean by that is they're in charge of their destiny. They control everything about this particular product or service that they are working with, and then automating everything. And this is core because some of the things we found is that without automation, the human handoffs and errors and repeatability, these are all issues that come up again and again and again. And so automating everything is key to enabling the teams to be so small. And actually, my boss has actually put something else here. He has a fourth tenet. It's an unofficial one. So manage the things that matter. And I agree with this one. So, and in this context, I think he's referring to things like modern applications. For example, they have a lot of moving parts. So rather than just a single application in a database, a modern application maybe comprised of thousands of services, each with purpose-built databases, and teams releasing new features continuously. These moving parts can be divided generally into two categories. So the first one is the activities that are part of the company's secret sauce. So what do we mean by that? Well, that's what makes your business or your product successful in the market. Creating a unique user experience, developing innovative products. So this is the core, the secret sauce. And this is what we want to be managing. But there are other activities, the second type of activities, which we can often refer to these as undifferentiated heavy lifting. So these are tasks that must get done. They have to get done for the business to function, to to be alive, but they don't provide any competitive advantage. So for most businesses, these could be things like server management, load balancing, applying security patches. So these are things that, good candidates for automation.
Hey, Matt, so just
sorry for
to
interrupting. Maybe you're not. I think you're not passing the slides. You're still on the cover.
How about now?
Yes, now I can see the 3 laws of Amazon DevOps.
Okay, so you missed a segue. Okay, fine. Okay, well, I'll leave that there for a minute, and then hopefully that's. I think it was paused for one moment. Okay, so we're on the third and the fourth official law. Okay, great. But let's take a step back. So we've got the 3 laws here, and this is where we are now. But let's take a step back to how we got to these laws. So how did we start out? So this is a sort of a familiar architecture for many of you, I'm sure, who've worked in software IT for a while, building software. So this is how many web architectures started out, and it's also how Amazon started out. So the giant monolithic bookstore application and the giant database that was used to power Amazon.com worked in a similar architecture to this, but it was limited with speed and agility. I mean, back then, Amazon had way fewer customers than they do now, but still, it was everybody was aware that was working on it that they wanted to expand the products and services that they offered, and they had to change the way the application architecture was approached. And most companies like Amazon start their business with a monolithic application like this because it's the fastest and easiest system to develop. But there are problems, with tightly combining processes and running them in a single service. If one process of the application experiences a spike in demand, the blast radius can be big. The entire architecture has to be scaled up to handle the load of that one process. Moreover, adding and improving features becomes more complex as the code base grows, making it difficult to experiment with and to implement new ideas. Monolithic architectures too add risk for applications availability because there's so many dependent and tightly coupled processes, increasing demand of a single process. So this is where the first iteration happened. This is like the first go at scaling. And in 1998, the Distributed Computing Manifesto came out, and then this laid out a blueprint for how to change architecture within AWS. With this manifesto, the architects could begin restructuring their applications into smaller pieces, services that enabled Amazon to scale. But it's still not perfect. You can see like things getting broken out a bit smaller. Things are still problematic. So some of the principles that were driven out of this for breaking things down are to make units as small as possible, sometimes called primitives. So within our company, we would break down into smaller units, and then start creating data domains. So try and identify which services belong to which domains and what their functions are. Start decoupling based on scaling factors, not functions. So how should this service work? How frequently is it used? If is it something that we need to scale horizontally all the time, vertically? And each service operates independently. So Jeff Bezos knew this, that communication is terrible. Us as humans, we're awful at communication and slow and indecisive. So if you work on a service that has all these sort of handoffs between others that you require communication, it will slow down the development of the service. So try to minimize the chattiness when developing the services is one of the principles, so we can operate independently. And then between the services and contracts as well, APIs to enable sort of smooth transition between the services. Again, this is like a communication between services. We don't have to have any sort of bindings here other than APIs. And this, we're talking about software here, and we're talking about architecture, we're talking about infrastructure, we're talking about the products that that drive the software and the solutions that we're trying to push as our business. But this isn't all about that as well. It also these principles lead to changes in organizations as well, and this is something that comes up a lot. So the two-pizza team principle. So a two-pizza team that owns a service, you should be able to feed that team on 2 pizzas. And now obviously this is debatable. If I'm hungry, I could probably eat 2 pizzas on my own. And some people might not like pizza, but the idea is this is a core rule of thumb on how things may work. It minimizes social constraints. If your team is getting so big that you can't feed them on 2 pizzas, this is sometimes a time to reflect and think about what exactly is the team doing. Should that be broken into 2 teams? And minimizing the social constraints with Conway's law. So one of his laws was that any organization that designs a system, sort of broad definition, will produce a design whose structure is a copy of the organization's communication structure. So in order to start with the architectural challenges, the organizational challenges are there as well. So this is something that applies, and this is something that applies to Amazon now. Amazon are very frugal with their teams, and this is one of the methods that they look to when they're building them. So how do teams get reorganized? So one of the principles here again is own everything. So this includes the planning, the security, the performance, scalability, deployments, operations, bugs, documentation, testing. So there's no handover between the development team and the operations team. One team builds, the other team deploys and runs, another team monitors. Maybe another team is there to plan. This is all done by the same team. This is information is fed in from customers maybe, but the team is there to control all of this. So how can one team do all this? Well, this is one of the challenges that comes up quite a lot. So automation is one of the key parts here to help, which helps Amazon do so little and with such small teams. So we look at here at continuous deployment, not just delivery. So and again, this isn't something you flip a switch and suddenly the software is being deployed to production on every check-in. This is something that happens over time. So more testing leading to higher quality and smaller releases. And when we say testing, automated testing is something that is critical here. Testing the things that matter. A fan-out model, so we're progressively closer to production with the software. And start from templates of best practices, and of course a pessimistic view. We want to find all the reasons why this can fail. I mean, I'm sure all of us have worked on build pipelines and come in or after lunch or in the morning and seen like a wall of red on our build pipelines. These are failures that we need to. This doesn't mean it's a failure. This means we found something excellent. Something's failed. We can have a look and see how we can fix that. So the next time it runs, it won't be read for the same reason. And security here as well. This is cool. This is everybody's job. This is job zero. But we don't want a security team here where their goal is to block things. That's not what we want. So everybody should be involved with security. Everybody should be involved early to ensure that this isn't an issue later on. So how do we manage the success and measure how well we're doing on the DevOps journey? So there are a number of metrics here, these suggested metrics that can help in measuring how well a team is doing. So business metrics around growth, usage, feedback, how this is all on the product. Customer feedback at AWS is critical. Most of our services our features are built from customer feedback and requests. So this is incredible, and actually getting that interaction with the end users is incredibly important. Operational metrics, so errors, throttling, failed deployments, performance. I mean, this is again a big one. Errors shouldn't be ignored. I've worked on systems that when they deploy, there's been tens of thousands of errors outputted. And this isn't good. These errors were generally ignored, and it's, well, if they're not adding any value, why are we surfacing these errors? Why are they there? How can we get rid of them? These are things that we should be concentrating on. Input goals like the features, the use case, the performance of the features. How can we measure those to see how well we're doing? And enablement as well. Enabling the teams to actually offer the best. So review, security training, ops training, learning new skills and new tools. So as organizations move from monoliths to microservices, many developers find that they want to manage dependencies within each services through a pipeline. They've had to create new ways of packaging applications and running code. And because of these innovations, instances are no longer your only way and your only compute option. So modern applications tend to do one thing well. This is harking back to the Unix philosophy. So we have independent deployments, independent scaling, small blast radius. So if our application does go wrong, how will that knock out the whole business? Or will it just knock out the bits that we've done? And can we fix that quickly? And do we have autonomy over the choice of technology, or is that governed for us by an outside team? Can we make the choice of technology ourselves? And this leads to other things like containers and serverless. So containers are so popular option for packaging code and a great tool for modernizing legacy applications because they offer excellent portability and flexibility over application settings. And with serverless movement, you get the most simplicity. The only code you write is business logic. We're not even worrying about the server side. So today we have these modern applications, and we need to think about some of the things that come with that. So the only way, there are other ways of communication as well. Many applications continue to use API connections. Maybe they use RESTful, sending data between services. But these aren't the only ways. We can consider streaming and real-time data processing, events for triggering responses, data changes, service meshes for application level communications and observability. So I think here is that there isn't like a broad stroke, a one size fits all. Choosing the integration method that best meets your application needs. So the services shouldn't be limited to like a one communication contract for all services throughout the organization. And the key here also is they're independently scalable microservices. We can deliver updates continuously. We can adapt to change. We're fault tolerant as well. We can deal with hardware outages, problems with the way we're hosting it in data center clouds, wherever we are, and we've got security built in. So this is where we were and where we're from. So the monolithic architecture, hierarchical organization, I mean, this is a long time ago, 2002, so nearly 20 years ago. Decoupled services, 2 pizza teams, thousands of microservices, hundreds of purpose-built databases. So, I mean, modern applications are built with decoupled data stores in which there is a one-to-many mapping of database and microservices rather than a single database. And this is an important shift from traditional application architecture, because just as a monolithic application poses scaling and fault tolerance challenges as it grows, so does the database. So with a single database, we have a single point of failure, and it's hard for a single database to meet the specific needs and a set of varied microservices. So by decoupling data along with microservices, we're giving ourselves a lot of freedom to choose the database that best fits our needs. So again, there isn't just one size fits all here for databases. Many people choose relational databases, but for many apps, there are very different data needs. For example, an application that works with lots of highly connected data sets, such as a recommendation engine, might use a graph database, for example. So the deployment change as well. So what we've seen here is with a monolithic deployment lifecycle, we usually have sort of the 4 core blocks: the build, test, release, monitor. And this is all sort of a one big bang deployment. And this doesn't fit nicely into the two pizza team. This is hard. This takes a team to keep this going. Deployments can take hours, if maybe even the whole day, to actually build and test and release and monitor this in production once it's released. So the way the microservice deployment lifecycle went was to break this down. One of the fundamental tenets we talked about right at the beginning. And this removes the coordination challenges of making and delivering updates. We've decentralized our development and release process, but this produces new challenges as well. This isn't like the silver bullet. So when all this was manual, it created all sorts of possible human errors. So this leads us to the modern software delivery. So this is generally the 6 steps if you include sort of the authoring step, so where we sort of build the solution. And the way this is sort of an AWS window into how a CI/CD pipeline may look with the tools here, but it's not hard to imagine how these could be replaced with maybe some of the tools you're using, or some of the common tools out there, the open source community. So I mean, this is and there's usually a two-pronged approach here. So standardization and automation. We define a software delivery process as a best practice template. We look at modeling and provisioning all our infrastructure resources in an environment. So we're using infrastructure as code templates here. So we get our team started on the right foot because the template provisions the entire tech stack for an application through code rather than using a manual process. More automation, this is great. At Amazon, this ensures the teams are configuring their processes and deployments according to requirements. And then the second thing is to use automation to remove manual process from the software delivery workflow. With automated release pipelines, continuous integration, continuous deployment, rapidly testing, releasing lots of code within, while minimizing errors. So with CI, our teams regularly merge their code changes into a central repo. Then they run automated builds and tests so that we detect problems early. And then with CD, our teams commit the changes multiple times a day and flow out to production, all without human interaction along this pipeline. So where does that lead now? So this is where the segue into the next part of the talk, where we AWS, we've got a couple of tools where we're looking into things that we sometimes call next-gen DevOps. One of them is Amazon CodeGuru. And so this is where we look at using machine learning to build and run high-performing applications. So this is on top of the CI/CD that we've had before. That for many organizations is quite mature. So what we're looking at here is further automation, looking at ways we can make our applications better, built-in code reviews with intelligent recommendations. So this goes way beyond static code analysis and tools that analyze codes in that matter. We can use machine learning to detect and optimize lines of code in pre-production environments, and actually identify inefficiencies in production environments as well. So this is a developer tool that aims to provide intelligent recommendations to improve code quality and identify an application's most expensive lines of code. We can integrate the CodeGuru into existing software development workflows to automate code reviews during application development and continuously monitor applications' performance in production and provide recommendations, visual clues on how to improve code quality, application performance, reduce overall costs. And the next thing as well here is DevOps, Amazon DevOps Guru. Again, this is another machine learning powered cloud operations service. And at this point, I'm going to pass on to my colleague, Raphael, to cover a bit more about DevOps Guru, as I believe this will be of interest to the DevOps group here, and give a small demo of what this is capable of.
All right. Yep. Thanks, Matt. I'll take over here the presentation.
Hi, Raphael. Thank you.
So, Do you see my screen?
Yes, yeah, we can see it.
Folks here. Okay, yeah. So let me start the presentation. Yeah, I guess right now you should be seeing my slide.
Yeah,
right?
we can see it. We can see it.
Yeah, great. Yeah, and again, thanks again for attending this workshop and for giving me the opportunity to speak with this community today. As Matt said, my name is Rafael. I'm also a solutions architect at AWS, but I'm based out of Berlin, Germany. And I worked as a software engineer for quite a while, I think over a decade right now. And at AWS, I support organizations with DevOps culture in general. And again, I'm really excited to speak with you today. So Matt covered pretty much how DevOps can be implemented, why you would do that, and what you have to change in terms of processes and culture in general. But with this set of tooling that we are bringing to the table at this point, we are putting AI/ML into this DevOps workflow, and the idea is to materialize what we are calling as next-gen DevOps. And I think this is a very good extension from what Matt just explained in the sense of the tooling that you can use to increase productivity and improve your automation. And my goal today is to walk you through what DevOps Guru actually is and where it fits in terms of next-gen DevOps, and also the typical use cases that developers, engineers, and operators would face on their day-to-day. I will also show you quickly, after this quick presentation, I'll show you in details how it looks like on the console so that I can better illustrate what the tool can do for you on your daily business. If you have any questions, please feel free to post on the chat and I will address those in the end. Yeah, so what you see here on this slide is a traditional monitoring setup, and this is how IT operations work today in most of the organizations. And you're probably very familiar with this kind of situation, this kind of rooms, if you are operating your systems, especially at scale. And regardless whether you are a small business or an enterprise company, the applications that you have right now in your hands, they are becoming more and more distributed and complex, especially with the advent of microservices. So it will demand additional dashboards, additional alarms, and metrics also that would allow you to monitor all those IT resources and the applications that you have on the table. And as you can imagine, maintaining and improving the application availability of all the microservices that you have on the table, and also resolving any operational issues that you have, are becoming even more difficult when you start to distribute your systems and to break down the monolith you have. And here are some of the key operational challenges. And I guess right now, most of you are facing that. If not, when you start working at scale, probably you face some of them. So every time your team adds a new service or maybe a new resource, let's say a new EC2 instance or a new Lambda function, a new table on your DynamoDB, once you add that, ops or your team, if you are working on a full DevOps setup, you have to complete the observability coverage of those resources. Maybe you have to enable monitoring, and probably you have to manually configure all the alarms and set the different metrics and define different thresholds for the resources that you're trying to monitor. And as you can imagine, probably you have done that. I've done that, and this is really painful. Defining the actual threshold for an alarm is very tricky. You really have to fine tune. All right, what's the correct threshold for my CPU? When should I start worrying that my EC2 instance or my virtual machine is actually on high capacity? Is it 60%, 70%? So it can be very tricky. And from an operational perspective, setting up all the alarms that you have, so many alarms, and collecting those aggregated metrics is really overwhelming as you increase the number of resources and applications you have. Also, when an issue occurs in production, you have to deal with a high number of alarms that are alerting. You have multiple things that might be beeping at the same time. And then you have to stitch together all those data points and try to correlate the failures to identify what is the actual root cause for that. What is the side effect of what you're seeing on your dashboards, and what is actually the root cause of the issue you currently have. This can take a significant amount of time, and because of that, your MTTR is affected and your customer is impacted. Now think about the number of alarms, metrics, traces that an operator has to track in order to root cause an issue of an environment with dozens of different applications. Let's say maybe even 100 of microservices. That depends on the size of your organization. And think about the number of alarms and the number of thresholds they have to enable just to have full coverage, full observability coverage. Another concern that I hear all the time when I'm discussing with developers and operators is that when the issue occurs, when this kind of issue occurs, they spend too much time, way too much time in war rooms trying to root cause those issues. And while you are in those war rooms discussing what went wrong, what can we do to fix it, your end customers are impacted with downtime or maybe poor user experience. Two common questions arise in those war rooms. At least those were very common when I was in those war rooms myself. The first one is, how can I minimize the impact of those issues? How can I enable the ops team or the DevOps team to root cause those problems as soon as possible, and of course recover the system more quickly so that my customers are not impacted? And the second question is, why am I even on this situation? Why did it happen? And is there any way to enable my development team to catch this kind of issue in time during code reviews? For the last question, we have a service called Code Guru that Matt mentioned briefly, and this is mainly for static code analysis, as he said, and also for application performance evaluation. But this is not going to be our focus today. Our focus is on the first question, which is how can I identify and root cause issues as quick as possible in production. And that's exactly how the DevOps Guru is exactly the tool that we created to help you on this journey. So in a nutshell, basically, DevOps Guru is a machine learning based service, and the idea is to make it easy to improve your application availability. And this is what I want to stress, and this is what I want to highlight today. This is the takeaway that I would like you to have from this presentation, which is increasing the application availability. This is a key aspect here. And the idea is that we reduce the noise from several different alarms and identify the critical issues to help you root cause those problems that you're having in production and therefore reduce the MTTR. Our approach towards what we call next-gen DevOps is to apply machine learning to the operational data of your applications and of your workloads, with the goal to improve the performance and improve the availability of your application. It's possible to do that with DevOps Guru because when an issue occurs, instead of having a complex dashboard with multiple alarms ringing, it will provide you with an intelligent digest that would put together the various events and the various anomalies that you have, so that the operator, or in this case you, can root cause the issue more quickly. So to make it clear, in case it's not yet, DevOps Guru is fully managed, meaning that it does not require you to set up or train machine learning models. All you have to do is to provide some guidance on the application boundaries that you have, meaning maybe the region or the AWS region where your application is running, or applications, or a CloudFormation template, which would serve as the boundary of your application. Those models are pre-trained, as I mentioned, and we used years of our own expertise to identify anomalies in our production system. So what it does, basically, it starts to monitor when you activate. It starts to monitor your application and to understand the usual behavior of that application. And after understanding that, then it will be able to tell you when an anomaly is actually detected. So if DevOps Guru, or when DevOps Guru identifies this anomaly, it will correlate an event and it will create what we call an insight. And in this insight, you see what went wrong, what was the possible event that caused this issue, and it will also give you some recommendations on how to fix the issue more quickly. It's also, DevOps Guru is also capable of automatically identify when you add or remove resources on your workload, and you don't have to manually set up multiple alarms or threshold. So enabling is as simple as clicking on a button, as you can see here on this screenshot, but I will show you in the console in a minute. So if you navigate right now to the DevOps Guru service page, you simply see a button to enable it. And as soon as you do that, it will start to monitor the resources on that particular account and that particular region, or maybe on a particular CloudFormation stack. And yeah, once you enable, you'd see a dashboard similar to this one that you see on the screenshot. So one thing here, you don't see any fancy graph, chart, or any run counter that you are probably used to when we are talking about monitoring. And this is by design. The reason for that is that instead of you monitoring or creating those dashboards and seeing what can be wrong, we offload that from you, and DevOps Guru will monitor the system health on your behalf and only notify you when an anomaly is detected. Under the hood, it will DevOps Guru will ingest the vended CloudWatch metrics of your environment, of all the resources in a specific region or in a specific CloudFormation stack, and it will also consume the events from CloudTrail, so that it can tell you which CloudTrail event was actually responsible for the anomaly that you're seeing right now. So you don't have to manually define those different thresholds and those different alarms. DevOps Guru will implicitly set the threshold based on the behavior of your application. Just to give an example, so let's say you have an application right now that is handling 10 requests per second. That's the normal behavior. That's the baseline that DevOps Guru identified for your application. Out of sudden, you start to get 1,000 requests per second. It could mean that you are under a DDoS attack, and DevOps Guru will notify you, hey, there is an anomaly here. There is something wrong in your application behavior. So you didn't have to set up any threshold here. DevOps Guru simply identified that 10 requests per second is the standard behavior. On the other hand, if those 1,000 requests per second becomes the standard traffic, DevOps Guru will adapt to that. You don't have to manually go there and say, hey, this is my new traffic. This is normal. No, it will identify that this is the new standard and adapt accordingly to that, and dynamically set a new threshold. So before I jump into the console and show you how it is, let me just explain quickly this application that I have running there, so that I can better we can better understand what I'm about to demonstrate. So in this case here, you see a simple serverless application that I spawned before using a CloudFormation template. And the CloudFormation template, as I mentioned a couple of times, is something important, because this is the boundaries for DevOps Guru. DevOps Guru say, you tell him, hey, this is my application, and this is defined by this CloudFormation template, and DevOps Guru will correlate the events based on those resources here from this template. So this is again, this is a very simple serverless application. You have an API gateway, you have a Lambda function, you have a DynamoDB table. So let's say that someone, in the example that I simulated before this presentation, someone changed the read capacity of a DynamoDB table by accident. Initially it was 5, someone changed to 1 and deployed that in production. At the same time, the traffic, the HTTP traffic to your website increased. And right now, the capacity of your DynamoDB table is just 1, and you have a very high traffic there. It means that your table will be throttled. DynamoDB won't have capacity to respond to all those requests here. And what will happen is the Lambda function that is reading from this DynamoDB table will start to fail, and the API gateway will start to respond with 500 HTTP errors. So in this common scenario, the operator would see all those 3 resources failing. They will see the API gateway error rate throttled. They will see the Lambda function number of errors also breached, and the read capacity of DynamoDB. Everything is failing. So what is the side effect, and what is the actual root cause of the problem that I have right now? So the operator will have to investigate and then try to fix the issue. And this is exactly how the machine learning detectors of DevOps Guru will help you. Once you enable, DevOps Guru will take something about 24 and 48 hours to have a proper baseline of your application. Just as you see in this diagram, it's consuming the metrics from CloudWatch, and it's also consuming the events from CloudTrail. And after detecting that, DevOps Guru will then provide you with an insight. And this is what I want to show you here on the console. So first, this is the dashboard. As I said, no fancy running counters, no pie charts, no graphs, nothing. All you see is the applications that is being monitored, the number of insights you have, impacted stacks by events and stuff like this. So you see here the multiple stacks that you can have on this account. In my case here, I have only 1. And when you go to insights, this is what you see. You see a list of insights that you have right now. In this case, reactive insights. You see the severity, the status of that, the number of affected insights, stacks, and the number of affected resources. And this is the insight that you see. If you click in one of those here, you see exactly the insight. That's an old one that I have. This is divided in 4 different sections. The first one is the overview of this section, some description of it, when it started, when it ended. It has also an integration with default integration with Ops item. So this is yet another service from AWS that I won't discuss today, but you will be able to see here an Ops item open so that someone can react on that. The interesting part starts to come now. You see here the aggregated metrics. In this case, it will show. By the way, you didn't have to set anything on CloudWatch. All right, this DevOps Guru picked automatically from you, and those are the metrics that have been breached. You see the error sum on the AWS Lambda. You see the read throttle events on the DynamoDB table. You also see the 5xx error average on the API gateway. As I mentioned, all the resources are failing. Which one is the responsible for the actual failure? If you want to see the graph for that, you can see here as well. So the DevOps Guru would put together the charts for all the resources that are impacted, so you don't have a messy view of everything. So if you have 1,000 resources and only 4 are impacted, you only see the 4 that are interesting for you. You also see here the related events. As I mentioned, I deployed a bugged CloudFormation template here, and it will show you actually. So there was an update stack event. This is the CloudTrail log that you see. Yeah, so it's gone. I think it has been deleted. Yeah, because this event is from June, and there is a retention period of CloudTrail, so you won't be able to see. But trust my word here, you would see an event here on CloudTrail showing exactly what was changed on the resources. And you also, yeah, this is another one when I fixed. Let me see if this is if we are able to see, or if, yeah, it's also done by the retention period. And here is the recommendations. This is the best part in my opinion. You see some things of what you can do to fix this issue. One of the recommendations here is roll back the DynamoDB table update. So this CloudFormation that I deployed here, that generated this event, was actually to reduce the capacity from 5 to 1. And this is what CloudTrail or DevOps Guru is telling me. Hey, you have a throttled request here, read requests, and there was an event that was an update table. You updated this DynamoDB table. Maybe you want to roll back this one and get back to the initial state so that this problem might be solved. It also puts together here some links to the official documentation on AWS. So how can I troubleshoot the DynamoDB table? Then you have a link here. My DynamoDB table is being throttled. So you have a direct link to the description on how you can troubleshoot that. And this is a shortcut, so you won't have to Google this kind of thing. Another, coming back to the presentation, the last slide, I promise. This also, DevOps Guru also has an integration with Opsgenie, PagerDuty, and there is an out-of-the-box integration with AWS Ops Center. So you can connect that to, if you are familiar with SNS, you can connect DevOps Guru with an ASNS topic that will then put the messages on Opsgenie and on PagerDuty, so your team will be notified when DevOps Guru identifies an anomaly. And that's what I wanted to show you today. Do you have any questions for us?
Thanks, Raphael. We've got some questions that have come in just sort of over the course of both presentations. So yeah, if both yourself and Matt want to join, and then we can start going through some of those. So the first one I have here just is on the DevOps side of things on AWS and Amazon. How does that work between sort of Amazon as a retail company and AWS? How do they share best practices, or is like Amazon retail a customer of AWS and they run their own? Oh, sorry, I can't hear you, Matt.
Okay, hi. Yeah, so we often get asked this. So Raphael and I work for AWS, and we often get asked, can Amazon see my data, or how are you affiliated with Amazon? So we're all under the Amazon umbrella, but Amazon are a customer of AWS, so they build their services on top of that. So I don't work with the Amazon teams; they're a customer of AWS. So we work on the cloud platform. Amazon are a customer to us just the same as anybody else would be. So that's the sort of differentiator there.
Cool. Excellent.
Yeah, also, but to add to that, sometimes you see services that were we created inside or Amazon created inside, and then they hand over to us some code tools that you see, like code pipeline, code build. Those tools were created using using Amazon best practices, because they scale there is so big, and then we simply steal from them and take over, and we can put them to customers to use those. It's the same with DevOps Guru, by the way.
Yeah, excellent. Cool. So the next one I've got is just on when you have the sort of two pizza teams, how do those teams communicate with other teams to say, well, okay, I need some sort of input, or I need some sort of data from somewhere else, to be able to say, right, these are my needs for my microservice. Do they collaborate together to figure out what each team needs, and what end users might need, or is it all internal to that team?
So it depends. I mean, so if it was, say, an external team, we manage our feature requests, our input pipeline as well that comes in to those teams. So there'll be a request about that. Maybe a customer is an internal customer or an external customer, but they will raise a feature request with the team. The team will look at it. They obviously prioritize. So we're small teams. We will look at these features, and we're very customer driven. If we find there's a lot of customers asking for a very similar feature, then what we'll do is we'll go out and gather data with the people who are asking, ask them questions. Well, why do you want this? Ask why multiple times. Try and get as much data about this feature as possible before we consider it. But yes, we will go back and work with them, collaborate, get as much information as we can on the feature to be sure that the feature we're going to develop is right for the product.
Yeah, excellent. So the next one I've got is how do you deal with data that's needed by multiple services? Do you end up with like duplicates of that data, or do you have like the data separated out in its own service? So say you have like a customer profile or something, you've got a service that needs to work on that profile, and there's another service that needs that as well. How do you keep that in?
So this is kind of this is going back to the microservices tenants, where you have a sort of a vertical slice where you might have a person's database, data there that's held all the way down into a database. So there are many ways of doing that. It depends on what the data is used for, how you keep it in sync. So one of the ways you can do that is to duplicate the data, which is often can be tricky because you've got to synchronize that between the back-end data stores as well. So it really depends. You can create a service around that particular data store and then share that between services. Maybe that might be one way of sharing it. Keeping things a bit of duplication may not be a problem, but it's a hard problem to solve. I concede that it's a difficult one, and it can depend. It can be situational.
Yeah. Okay. Excellent. So the next one I have here is, how does the split of sort of team responsibilities work with something like, say, like EC2, like the Amazon team that's responsible for EC2? do the teams like go on certain parts of it? So like, is there a Nitro team, team is dealing with how it interacts with security groups? Is that all separated out in teams, and how do they sort of work together to get an EC2 release out? Or maybe not, EC2 is maybe not a great example for that, but something like that where you've got one overarching product and multiple teams within that.
I get you, Raphael. I don't know if you have anything here. Otherwise,
you mean about the our 2Pizza teams internally?
Yeah, just how the teams sort of work together to make a sort of larger product release if they're working on their own part of it. But there's, say, you're releasing the actual the product itself. How do they coordinate to make sure that they're working together towards that release?
Yeah, we are very strict to what Matt presented on his share, in the sense of the teams have autonomy. It's about what works for them, and you can see, for instance, imagine a service like S3, one of the most popular ones. As you can imagine, we have several teams that are working on this service, and those teams a team can be responsible for a smaller feature set of that. And we don't want the whole S3 teams to be using the same practices and in the same way. It depends on what works better for that team. And you would see teams that say, yeah, I want to use directly the tools, the DynamoDB or whatever, and you can see another team that prefers to use something else because that works better for them. And even when it comes to the agile methodology that they are using. What is the same is I can mention is about how they handle events, for instance. And this is a misconception that we see all the time, which is how a developer, when they usually imagine that they would go to a DevOps journey, and now I'm responsible for the application to operate the application as well. It's more work, and I'll be on duty all the time. But it's not really, because there is support, and then there is a very strict process for that. So you need to have your run books, so that support will help the customers with that before you are being paged. So your work is to keep those run books and playbooks actually in shape, and this is cross organization.
Okay, cool. Oh, that sounds good. So I've got one here just on Code Guru. Just a question. This is probably, it might be sort of in the actual machine learning side of it, but how does Code Guru deal with code that performs differently and under certain conditions? So like, if you've got a high load, you might have a query that's not optimized, but it works perfectly fine for a few requests. How is it able to detect that line might be more impactful if there's a high load, for example?
I'm sorry, can you repeat, John?
Sure, yeah, it's is Code Guru able to detect a line of code that might work fine under a small load, but under a bigger load might actually be an issue and may cause ongoing impact?
Okay, yes. The answer is no, it won't be able to detect on that sense. But Code Guru has something we call Code Guru Profiler. So it will actually see what's going on there on your code, and you'll be able to evaluate on a given period of time, for instance, and that could be the spike on traffic, and you can see even the dollars, how much you are wasting with that single line of code in terms of money.
Right, okay,
so you can isolate by the time frame.
Yeah. Okay. Cool. One just here on DevOps Guru. In terms of the sources of the data that's able to analyze, is that just coming from CloudWatch and CloudTrail, or can you feed in other sources like from like Datadog or Splunk?
We want to do that to support other sources, but for now, we ingest vended CloudWatch, the vended CloudWatch metrics that you have there, so it's automatically consumed from CloudWatch, and the CloudTrail events, as I mentioned. But we do want to support other sources as well. And by the way, DevOps Guru is not intrusive, so if you enable it, it's not going to change anything in your environment. It will simply read those events.
Yeah, cool. And I should a sort of slightly related question to that in terms of CloudTrail. Does DevOps Guru work with sources that are in other accounts? So if you had, say, you had a centralized CloudTrail log in another account, would it be able to ingest that data in terms of monitoring an application? So say you had a dev, test, and prod account, and you wanted to use DevOps Guru on your prod account, but all of your CloudTrail logs are in a centralized area. Is that something that, would it just be a case of sharing access to that CloudTrail log?
No, DevOps Guru is account and region based. You have to specify the account and the region, and it will get data only for that.
Only from that one.
And this is actually, this is not something I would recommend in the sense of you get your production environment and you are consuming data from the staging and dev, because it would the DevOps Guru would understand wrongly the typical behavior of your application.
Yeah, so we'll have all the applications there. Cool.
Yeah.
I think the last one I have here just is just on the sort of alerting process. You mentioned that it will alert when it sees an issue and there's links into like Opsgenie, PagerDuty, etc. So what happens when the issue starts happening? Does like if you've got alerts set up on the actual metrics, I take it they'll still fire, but does the actual DevOps Guru alert when it sees a sort of combined issue, or does it alert when it starts to see alerts coming through?
It will alert you. We are very careful with how is it called, false positives. So we want to generate the insight only when we are pretty much sure that there is some actual anomaly there. And once the anomaly is detected, you see that insight that I showed on the console, and that's when you get notified.
Okay. And what is there a delay there in terms of first identifying it, or how quick is that process? If you start seeing like 500 errors spiking on your API gateway, how long would it be for the insight to recognize that there's an issue there?
That really depends, because since it's based on machine learning, it's not deterministic. So it can be that the exact same occasion would be 1 minute, and in another situation would be 40 seconds. So it's not deterministic.
Yeah, okay, that makes sense. So yeah, I don't have any other questions at the moment, unless anyone's got anything else that they would like to ask. We'll just give a few minutes just to see if there's any more sort of questions coming in. Yeah, just in the meantime, just wanted to extend my thanks to Matt and Raphael for joining us. It's a really enjoyable talk. I really got some good insights there from the DevOps and the Code Guru and DevOps Guru side of things. Yeah, and I think we'll say thanks and leave it there. And thanks everyone for attending. I hope you enjoyed the presentations and gained some good insights from it.
Thanks for the opportunity. It was a pleasure.
Thank you.